As an application grows, you'll want to collect your code into modules to better organize and manage it. Writing modular code also helps you reuse logic and functions without duplicating code you've already written. We will reuse the API requests and transform functions we wrote earlier for the ETL pipeline in our API proxy. For our API proxy, we will reuse the API requests and transform functions we wrote earlier for the ETL pipeline by extracting them into a module. In this tutorial, we're going to take code from another application and put it into a module to use in a new project. We'll also talk about the benefits of creating modules to hold our code. First, let's install the dependencies that we'll need. In the terminal, let's enter the project folder. So far, this project is just a basic Express server like we created in a previous tutorial. Now we'll install request and request promise from npm. You'll see a deprecation notice about request. That's to be expected. Request has been deprecated, but it's still functionally sound, so we'll be working with it. Next, we'll create a directory and file to hold our module. In the project root, create a directory called exoplanet and an index.js file inside the directory. The exoplanet index.js file will hold the code we're going to be exporting. Later, when importing the code with require, you'll be able to pass just the path of the exoplanet directory, and require will find the index.js file inside it automatically. To be clear, it's not necessary to use the module name /index.js convention of creating modules in a directory. You could create a file called exoplanet.js at the root of the project and require it in the same way as above. We've used the directory approach mostly out of habit, but putting your modules into their own named files is completely valid as well. Now let's open the exoplanet /index.js file and copy and paste the code we wrote earlier for interacting with the exoplanet API and transforming planet records. You can find the code to copy and paste in the written part of this tutorial. We're also going to be adding a new API call to this file that we'll be using for the API proxy. You can copy-paste in the get planets discovered since year function as well. To export the code from the module, we override the module.exports object with a new object containing the functions we want to export. In this case, that will be get all planets, get planets discovered since year, and transform one planet. Once code is assigned to module.exports, it can be imported into any file it's needed in the application using the require function. That's essentially it for creating a module. To test that everything is working, let's create a Scratch file and import some of the code from our Exponents module. We'll pass the path to our exoplanets directory to the require function and use destructuring to import the functions we want from the file. Let's test out the get planets discovered since year function, passing it 2020 as the year. We'll map over the returned planets and transform each record with transform one planet. Then, let's console log the result and add a catch handler just in case something goes wrong getting the data. Let's run the Scratch file from the terminal. And if everything is working, then we'll see our transform planet records logged to the console. Now we have all the code that interacts with the exoplanet API organized into a single module that we can access from any part of our application. We'll use this module in the next tutorials as we build the API proxy. But now we have a single place in our application where this code lives. To recap, in this tutorial, we took code that interacts with the NASA Exoplanet API and organized it into a module. We used module.exports to export code from the file so we could import it elsewhere in our application. We talked about how creating modules allows you to organize code you'll be reusing or that serves a specific function into a single file, making that code available to be used in other parts of your application.